In the last video, we have seen the basic features of state machines. Any digital system is known as a state machine. This is a basic model. It is having X represents the input, Y is the output. The system is also having different states. These are the states, and it will be fed to memory, and whenever needed it will be fed back to the original system as well. So this is the basic model of a state machine. Now there are two models of state machines, Mealy machine and or Mealy model. The next is the Moore machine or Moore model. So first I will be explaining what is the meaning of Mealy machine or the Mealy model. In a Mealy model you have to represent input, you have to represent the output, also you have to represent what are the different states, etc. in a particular way. For example, a 2-bit system. Since it's a 2-bit system, we know that there will be 4 states: 0, 0, 0, 1, 1, 0 and 1, 1. So first I will be drawing the states 0, 0, 0, 1, 1, 0 and 1, 1. And I assume that this is a one particular example question. It's a random example. Depends on the question, you have to find out what are the states and other things. So these are the states. Now the system is having input, at the same time it's also having output and states also. So first I am telling, when the value of x, this is here, when the value of x equal to 0, and if the system is in this state, assume that this is a starting state 0, 0, and if x equal to 0 in this state, based on the question you have to represent what is the next state. As an example I am writing, if x equal to 0, it should go to second state 0, 1. So I am writing x equal to 0, it should go to state 0, 1, and also we have to specify what is the output. So I am writing, based on the question I am writing, y, the output is equal to 1 in this case. It can be 0 also, it depends on the question. So from 0, 0 it is shifted to 1 if x is equal to 0. Now x can take other value also, x can be 1 also. That also you have to specify. If x equal to 1, in this example I am writing, if x equal to 1, it should return back to its original state. X equal to 1, it should return back to its original state. You also have to specify what's the value of output. I am writing y is equal to 1 in this case also. Now remember that these are example values, you can put 0 or 1, depends on your question. Now this is the way you can represent the state for 0, 0. X equal to 0, you should represent what is the next state. X equal to 1, you should represent what's the next state. Specify output also. Now we will take another state 0, 1. This is the present state. And you again here also two options. When x equal to 0, what's the next state, and x equal to 1, what's the next, you have to specify. I am writing when x equal to 0, it should going back to 0, 0 state, and also you are specifying in that case y is equal to 0. Now the next option, x equal to 1, I am writing x equal to 1, it should go back to state 1, 0, and you are writing like this, x equal to 1, and also specify your output. Example, I am writing y equal to 1. Now the state is 1, 0. Here also two options, x equal to 0 and x equal to 1. X equal to 0 I am writing, it is going back to 0, 0 state. X equal to 0, it is going back to this state, and also representing the output in that case. Based on the question, it can be 1 or it can be 0. I am writing 1. Now x equal to 1 in that state, assume that it is going to this state. So I am writing x equal to 1, output also equal to 1. Now the one more state, that is 1, 1. I am writing when x equal to 0, it is returning back to its original state. In that case output is equal to 0, and x equal to 1, it may go to 0, 0. In that case output is equal to 1. It all depends on your question, where is the next state and what is the value of output. It's all depends on your question. These are just example values. I am just telling you the representation. How do we represent the states, input and output in a Mealy machine? Okay, so this is a way to represent. Also we can simplify this representation. To simplify this, first again you draw to the state 0 0 0 1 1 0 and 1 1. Now this is the way to represent. In a simplified manner you can represent. You have written when x equal to 0, y is equal to 1 in this state. So I am writing like this. Go from 0 0 to 0 1 and you are writing like this 0 bar 1, which means this 0 indicates x input is equal to 0 and this 1 indicate y output. So the meaning of this is when x equal to 0, the system should change its state from 0 0 to 0 1. At that time output will be equal to 1. Okay, now I am representing this state from 0 0. If x equal to 1, it is returning back to its own state. So I am representing like this. I am drawing like this and I am representing 1 bar 1, which indicates x equal to 1. This x equal to 1. In that case y is equal to 1. This is the meaning. Now this I am representing 0 1. When x equal to 1, it is going back to 1 0. So in that case x equal to 1, y is equal to 1. So you are representing 1 bar 1. Okay, then x equal to 0, y is equal to 0. So you will be representing like this 0 bar 0. And in this state, if x equal to 1, y equal to 1, so you will be representing 1 bar 1. And here x equal to 0, y is equal to 0. So you will be representing 0 bar 0. And here x equal to 1, y equal to 1, 1 bar 1. So if you see this kind of representation, this is a simplified model for a Mealy machine representation. Now the conclusion in this Mealy model is, if you are representing any digital system in a Mealy machine model, the output, that is this value 1, this 1, this 1, this 0, this 0 and this 0, these are the 1, this output. So the conclusion of the Mealy machine is output depends on present input and the states also. This is the conclusion. The output, this value of output depends on the present input, that is this 0, and at the same time the state also. It is dependent on the states. So this is the method to write in a Mealy machine. Output depends on the present input and the present